Hi everyone and welcome to the internet. So what we're going to be doing in today's lesson is having a look at pure and impure substances. So hopefully by the end of today's lesson you're going to be able to describe what on earth this purity thing is and how we can actually work out if a substance is pure or not. So first thing I'd like to do in your books is have a go at answering these two questions based around our previous lesson. So I'm going to give you just about a minute and a half to have a go at answering those in your book. Okay, let's check those answers then. Hopefully we do know that the empirical formula is the simplest whole number ratio of the atoms of each element that we find in a compound. If you got that definition, give yourself a tick. If you didn't get it right, then obviously write down the correct answer. For number 2, when we're writing the empirical formula for C20H40, then what we need to do is find the highest common factor of 20 and 40, which is 20 in this case, and then we divide 20 by 20 gives us 1, and 40 by 20 gives us 2, so that gives us the simplest ratio of C1H2, which we just write as CH2. Do make sure that when you're writing that 2, it is in the subscript position, so that means in the bottom right. Things like your scientific notation are really important to get right. So add it up, give yourself a score out of 2 for your starter task. What I've got for you on the screen at the moment are two pictures. On the left we've got a picture of some muddy water that we dug out of a stream, and on the right we've got a picture of a jar filled with water from a tap. So two questions for you to answer in your book. First of all, is the water in either jar pure? And secondly, how can we make it pure? So I'm just going to give you about a minute and a half to write your answer in your book for this. hopefully we all said that actually neither jug has pure water in it. The one on the left quite clearly isn't pure, and I hope we all got that one right. There's actually bits floating around in there, so hopefully we didn't say that one was pure. The one you might have said was pure is the jar on the right. Now, even if the water comes from our tap, it's not just water molecules. We've got other ions that are dissolved in there. And particularly if you're living down near me in Kent, where we've got all this chalky soil, then as the water passes through that, it picks up lots of things like calcium, and then it leaves you those lovely watermarks on your sort of bathroom walls and screens and things like that. So in order to make the water pure, we've got to remove absolutely everything except those H2O molecules from it. That's the only point it's pure, is when there is just that one chemical compound present. So what we need to really understand then are a few of these key scientific terms that we're going to be using throughout today's lesson. So pure, impure and mixture are the first three that we're really going to look at. So a pure substance is one that consists of one element or compound. That's it. Just a single element or a single compound. That's all there is present. That's a pure substance. Whereas an impure substance contains more than one element or compound. So it's quite nice actually, because if you learn that a pure substance consists of one element or compound, then you kind of know what impure is, because it's just the opposite. And the last one, a mixture, I've left for you to fill in. So write down the definitions for pure and impure substances, and then have a go at writing your own definition of what a mixture is for me. So I'll leave this for about a minute and a half to give you a chance to get that done in your books. I'm hoping that we remember this definition of mixture from your Key Stage 3 work. So when we're talking about a mixture, that's a substance that consists of two or more substances that are not chemically joined together. So that second part there about them not being chemically joined together is really important. So mixture, substance that consists of two or more substances that are not chemically joined together. Make sure you got that definition if you didn't already have it written down. If you did, give yourself a tick. One of the key mixtures, if you like, and something we're going to come back and visit in C6, I believe it is looking at air. So the air that you're currently breathing in is a mixture. So what I want you to do is finish off that sentence for me. Now again, during your Key Stage 3 course, you probably looked at the composition of the air on Earth. So I'm hoping you can remember some percentages and some names for me there. And the second one there, an alloy, is again a term that you could have encountered at Key Stage 3. So have a go at finishing off those 2 sentences for me in your books. And for the first one, try to include the percentages and the names of the things that air is a mixture of, if you can. Okay, let's see what we actually know then. The first one, when we talk about air, as we've said, it is a mixture. So we've got more than one substance floating around in this stuff we're currently breathing in. Now, air is a mixture of gases, and the ones we need to know are listed on the screen there for you. If you can learn the names and percentages of these now, then you're saving yourself time when you finally come on to C6, because you are going to have to know those when you come on to look at the atmosphere. So what we've got that make up the air of Earth's atmosphere is 78% is nitrogen, 21% is oxygen, 0.04% is carbon dioxide, and 0.9% is argon. Now there are also other gases around, things like water vapour and so on, but the water vapour particularly is going to change in the amounts present day by day, hour by hour even. So we don't actually list that as a percentage. The other ones, they're pretty constant. And the second part, an alloy, this is a mixture of a metal and at least one other element. Now that other element may be a metal or it may be a non-metal. So one has to be a metal, but the other one may or may not be a metal there. So make sure you've got those points written down. I'll just leave that up there for about 30 more seconds in case you still need to do that. Obviously, if you got those right, give yourself ticks for anything you did get right. You may well be thinking this is just a whole load of definitions in today's lesson, and yeah, pretty much is. So the next one we need to do is a definition for melting point. So just write down in your books for me a definition for what melting point is. Just going to give you about 30 seconds to do this. Let's check those definitions then. Now, hopefully what we've got written down is the definition that states that melting point is the temperature at which a substance changes from a solid to a liquid. Now, this should be reminiscent of some of the work you did in the first physics unit, so P1, because there you were looking at obviously the change of state, and you've probably refreshed your memories of the work you did back in about year 7, all those years ago now, I know, where we looked at the change of states between solids, liquids and gases and named each of those processes. So hopefully we remember that going from a solid to a liquid is melting, and therefore the melting point, quite logically, is the temperature at which a substance changes from a solid to a liquid. So make sure you've got that written down if you haven't already. I'll just give another 30 seconds in case you're still writing. Now, the reason that we're actually concerned with melting point then is because this is how we can determine if a substance is pure or not. So what we find is that a pure substance, so a substance made of only one element or compound, that will melt at a single temperature. Whereas if we've got an impure substance, so one that's got more than one element or compound present, then what we're going to find is that melting point isn't going to be a single temperature. It's actually going to melt over a range of temperatures. And the points at which it's going to melt will actually be lower than that of the pure substance. So there are two ways that we can identify that we've got impurities present within our substance. Because if we know the expected melting point for the pure substance, we can do an experiment and see, does it melt at that temperature? If the answer to it is no, then we know it's impure. And we'd expect it to actually have a melting point lower than the pure substance first of all, and for it to melt over the range of temperatures there, not just a single temperature at all. So make sure you've got those points written down, just explaining why melting point is important to us when we're considering the purity of a substance. I'll leave it up there just for a couple of minutes so you can get those points written down. What I've got for you here then is a question for you to have a go answering in your book. If the difference in melting point is large, what does that tell us about the purity of the substance? So have a little think and then write down your answers in your book. What does it tell us about the purity of a substance if we've got a large difference in melting point to what we'd expect? Just going to give you about a minute to do that. Hopefully what we've written down is that if we've got a large difference in melting point, then we've got a lot of impurities present. So the larger the difference in that melting point to what we'd expect it to be, the greater the amount of other substances that are present, so the greater the amount of impurities present. Make sure you give yourself a tick if you got it right. If not, then jot down the correct answer for me. So 3 things I want you to have a go at doing now then. First one, how can you determine the melting point of a substance? Second, write a description of how to do that. And finally, make sure you include key details about the procedure. So have a think and then write your answers in your book for those 3 points for me. I'm going to give you about 3 minutes to have a really good go at this. So the most basic of answers, first of all, we determine the melting point by heating it. If we want to change something from a solid to a liquid, we heat it up. So that's our first thing, is we determine the melting point by heating it. Now, in order to actually work out the temperature at which something melts, we're going to need to use a thermometer here. So what we're going to do is record the temperature that it melts at, or we can record the temperature at regular intervals and then we can plot a graph and read it from the graph later. Now, in terms of a couple of those key points that we should consider here, first one is the speed at which we're going to heat the substance. Now, if we were in the lab, I'd have given you some ice cubes and asked you to determine the melting point of them. Which point I expect someone in the room would have put it above the Bunsen burner, whacked it on the highest flame possible, and then tried to work it out. That's not going to work, folks. The whole idea here is we heat the substance slowly. Now, the reason that we're going to heat the substance slowly is because it's going to allow the temperature of the whole substance to increase, not just the bit that's closest to the point that's being heated. The second thing we need to consider is the stirring of it. Now, as something melts, we need to actually stir it in order to make sure that that temperature is the same throughout the whole substance. So we're distributing that heat throughout the substance. If we don't stir it, then what we find is you end up with a real hot spot where the Bunsen burner or the hot plate is in contact with the actual substance, and it gets cooler the further away you go. We stir the substance as it melts to ensure that that whole sample is at the right temperature. So make sure you've got those points written down. In case you haven't, I'm going to give you just another couple of minutes to get that done. So last thing for today are the plenary questions. Those of you with a target grade up to a grade 5, it's the 2 on the left. Those of you with a target grade over a grade 5, it's the 2 on the right. So I'll leave this up just for a few seconds today, so I'd suggest hit pause on the video now so you've got a chance to answer these questions in your books. As always, you can find the answers to the plenary over on my website, scienceright.weebly.com. You'll also be able to find that under the Internet tab. Just select the week that we're in, and then you'll be able to find things like the lesson PowerPoints, the answers to the plenary, any additional work, and if there's any little experiments I thought you could do at home, then they're there too. So have a look and get using that.